Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We are in part 2, or the second video in my TTL based logic series. This is taking a look at the 7400 LS series, and we're looking at the 74LS02. Now this series is basically a reference for each chip that I have in the LS series. I'm going to show you how it works, how to hook it up, and its applications. So the 74LS02 is a quad 2 input NOR gate. So it looks like this. It has 4 of these chips on there. So you have A, B, and the output equals A, or not, that's not or. A or B, and it's inverted. So if we look at the truth table, we have A, B, and our output we have 0, 0, 1, 0, 1, 0, 1, 1. So if A and B are 0, so it's going to be opposite of that, so it's 1. If A or B is 1, it's going to be a 0, and 1 is high, so it's a 0, and both are high, it's a 0. So that is the truth table for a NOR gate. And if you watch my video on the LS00, that was an AND gate, or a NAND gate, I'm sorry, and it is a universal gate, and this NOR gate is also a universal gate, so you can connect them in different different configurations, and you can make a NOT gate, an OR gate, or an AND gate, just by combining some of these NOR chips. So if all you have is NOR and all you have is AND, you can make all the other gate circuits. So let's take a look at the data sheet here. Here is the data sheet. Here is our DIP package right here, dual inline package. We got pin 14 is connected to your VCC, so that's going to be in our case plus 5 volts. Here's our ground. So, and then you have this section here. You have that is 1. This is a second. It's actually number 3, but that's how they're connected. Just trying to use different colors here. So then you have these 3, and you have these 3. So this right here is your, these 2 would be your in, and this would be your out. So same difference. So your out pins are 1, 4, 13, and 10, and 10, and then your in pins would be 2 and 3 for that one, and 5 and 6 for that one, and 12 and 11, and 11 and 8 and 9, 8 and 9, So that's how that would work. So if you have an output on one of those four, there's your inputs. Now let's take a look at how it is universally compatible to make all these monitors. I can never find my mouse. Okay, let's take a look at this diagram here. This is your standard NOR gate. This is the symbol for a NOR gate, and as you can see, the circuit is open and I am having the LED light up. If I put a high on any one of these, the LED immediately goes out. If the high is on both, it stays out. So that's our truth table. Now, if you need an inverter, you can hook both inputs up to one input, and as you can see, it's on and now it is off. There is my inverter. And you can string these along if you wanted to invert it back to positive when it's on. Now for an AND gate, you connect one NOR gate, you take both inputs to an A input, and then on the second NOR gate you both inputs to a B input, and then both those outputs feed into the inputs of another NOR gate. And as you can see here, if I turn one on, the LED is not on. If I turn another one on, the LED is on. So AND is, when they're both on, it's on, but when only one is on, it is off. So that is your AND gate. And if you wanted a NOR gate, you could slap an inverter in the front of it. Now if you wanted an OR gate, you just need two NOR gates, and you connect an input A and B to the first, and then that output goes to both inputs on the second one. And as you can see, the LED is off. 5 volts to this one, 5 volts to this one, and then at both of them, there you go. So this is how universal the NOR gate is. And now if you saw my series on how these are constructed with transistors, that's different than the CMOS chips in the CMOS series. These are done with standard transistors that are tiny and put into the chips. So let us take a look at the circuit. Here's the circuit I designed. So I have, let's start the simulation. So this is your standard OR gate, NOR gate right here. So the output to the inputs to the NOR gate are low, so the output is high. If I make either one of these high, the output goes low, so that's a NOR gate. And if I click them both on, there you go. So in this instance, I made an inverter, so the output is low, and I can make the input is low, so the output's high, and there is that. This is an AND gate, so both of these need to be on for it to be on. And then this one is an OR. So either one, and if they're both on, it's on. Now all these were made with NOR gates. I had to use a 74HC02 because Tinkercad didn't have the LS02. The pinouts are a little bit different. The outputs are in different locations. So, but I have the LS chips set up down here, and we're gonna take a look at hooking them up now. Alright, here we go. So we have this. Alright. So right down here we're going to hook up our standard NOR gate. Couldn't talk, words were hard. So if you take a look here, I have power pin on 14, and then I have ground on pin 7. So my inputs are 2 and 3, and my output is on pin 1. So what I'm going to do is I'm just going to use regular jumper wires. So I'm going to hook up my first input to 3 and my second input to 2, and then I'm going to hook my output pin 1 to my LED. And if this is working correctly, I'll turn on my power supply. It is not working correctly. There it goes. It's just something was tied low in the beginning. So there is the NOR gate. They're both 0, so the LED is on. And if I press one, it goes off. I press the other, it goes off. I press them both, it goes off. So there is the standard NOR gate with one of these LS02, 74 LS02. So now we're going to look at this one over here. This is going to be the inverter. And the inverter is going to go. Now for the inverter, I tied. Well, that's not right. So I need to tie input 2 and 3 together. So input 2 and 3 together, and that is going to go to my switch. And then from input pin 1 is my output. That will go to my LED. And it's on, and then I can invert the signal. So see, if I tied all the pins on this one low, it wouldn't give me that weird startup. So that is the inverter. Let's come up to here, and this one is going to be the AND gate, so this one's a little trickier. I'm actually going to pull up my eye circuits. So the AND gate is, I need to tie 2 inputs together for my A and B. Just getting out the little wires. Okay, so I'm going to tie input to pin 2 and 3, which is my A and B input, and then I'm going to tie together pins 5 and 6, which is my inputs for my second NOR gate. So now I'm going to hook up. I don't think any of these wires are going to reach. No. So I'm going to get some jumpers here. So I'm going to go to my A output, and I'm going to plug it into this first one at pin 3, this one into pin 6, and now I'm going to take my output from that NOR gate, which is pin 1, pin 1, and I'm going to tie it to pin 11, which is the input for my second NOR gate. Then I'm going to take the input from the B input, that NOR gate, and I'm going to tie it to 12 because that is my second input to the third NOR gate. And then I'm going to take my output of that one, so pin 13, to my output LED, which is red. So this should be an AND gate. So if I press 1, nothing lights. If I press them both, the output lights. So AND 0, 1, 0, 0, 1, 2, 3, and on 3 they light. So that is NOR gates making an AND gate. Now we're going to make an OR gate. So we're going to come in here and we're just going to use the first one. Turn my power off. So switch A is going to go to the pin 3. Switch B is going to go to pin 2. No, I'm going to change that. I'm going to use pin 5 and 6 as my inputs. And then the output, which is pin 4, will go into pin 3. And also pin 2. So pin 1 and wow, some of these times these wires are difficult. Sometimes you just have to try over. There we go. I'll just tie it like this. Okay, so the output of that NOR gate is tied to the inputs of a second NOR gate, which is pin 2 and 3, and then I can take the output off of 1, plug it into my LED, turn the power on, and I have an OR gate. If you can see that, let me put that back on there. So 1, 1, so 0 off, and then 1, 2, 3 are all ones, and that's the truth table for an OR gate. So as you can see, the NOR gate, I was able to make the NOR function and also the 3 basic gates that make up most logic, actually all logic, and they're just combined to make more complex logic. So as a review, this is our NOR right here, this is our inverter, this is our AND, and this is our OR, all with the same chip, the 74LS02. That's going to do it for this video, guys. I hope you enjoying this series. You know, it's a good reference. The title is going to have the chip number if you need to jump back and know exactly the pinout and stuff. The video will be there. I'm also going to add some stuff to the description of the videos as a reference. So thank you so much, and I just want to put out my social media and also my Patreon page, where I'm going to be linking the Tinkercad stuff and the iCircuit stuff so you can take a better look at these chips. But thank you so much.